In this video, we're going to look at section 2.2 again, the derivative at a point. The derivative at a point. The notation for that we were saying was f prime of a. This is what we had introduced in the previous video. So I just want to run through another example real quick. Let's take a look at the function f of x is equal to 2x squared plus 4. You can see this plot over here. Okay, increase the plot time, right? And maybe increase the time, decrease the time spacing, and this should look like your parabola that has a y-intercept of 4. Okay, so you can see the parabola here. Okay, what we are considering is what is, for example, f prime of 2. What is that equal to? Well, according to the limit definition, it is the limit as h goes to 0. Remember, h is our spacing. F of 2 plus h minus f of 2 divided by h. Okay. So let's take a look at. Let's see if we can guess. Let's see if we can guess this limit. In the sense of what our table of values looks like. So if you take a value h, looks to be in this problem that we are choosing h is equal to 0.5. Okay, and our value that we are concerned about is 2. What is the average rate of change? Average rate of change of this function f of a plus h minus f of a divided by h. That is the average rate of change over the interval a plus h to a. Okay? So I think we can see it in the table. The value is 9 for the average rate of change when the spacing is 0.5. Let's make the spacing 0.1. Okay, let's make our spacing 0.1. Okay. And we need to increase the, let's see if I can get it to be 0.1 here. And we need to increase the plot time until we get to 2. So let's go for more time. Let's increase this plot until we get to 2. Okay. And here you can see the value 2 and 2.1. So the average rate of change from 2 to 2.1 is given by the value 8.2. So this will be 8.2. Okay. Well, what if you go to 0.01? Okay. 0.01. See if I can do that. 0.01. And plot this for time, and you can see that we haven't, these are all these values. I haven't quite gotten to 2 yet, which is the point that we were interested in. We were interested in this point 2, so I need to scroll back up here and create some more time and then see if we can find the function value. So let's go for more time. Okay, that should probably do it. Let's scroll down here until I can see the value 2 for my x. Okay, keep scrolling, and there we go. Finally, here's our value of a is 2. I'm going to look at the average rate of change from 2 to 2.01, and that will give me 8.06. 8.06. So this is the function evaluated at 2.01 minus the function evaluated at 2 over 0.01. This is my h. Here is my a plus h. And 2 is my a value that I'm interested in. So can you see what the limit is going to be? If not, let's try one more of these. So this is definitely a process. So if you're into the numbers, you're in for kind of a tough time because you have to compute a lot of these numbers. So let's plot this for more time. Okay. And let's watch these all scroll by. So notice that my time spacing is, what is it? Oh, can I even go a little smaller? No, it's 0.01. Nope, looks like that's as small as I can go, 0.01. Okay. So I guess we're just going to have to take a guess at this value. What do you think, if you were given these tables of values, what do you think f prime of 2 is when the function f of x is equal to 2t squared plus 4? I'm going to take a guess that f prime of 2 is approximately, I'm going to say this probably is getting close to 8. Just taking a guess there. So what we need to do now is we need to prove. So what we need to do now is for the derivative at a point, we need to prove, and what I mean is just do the computation, prove that f prime of 2 is equal to 8. So if you're kind of interested in moving past the tables of values, then you're really going to need to get used to doing these limit problems. So the limit as h goes to 0, the function evaluated at 2 plus h, minus the function evaluated at 2, divided by h. Why the 2 value? Because that's where I'm asking you to find the derivative at 2. So here is f prime of 2. 2 is your a value. This is a plus h. This is a. There's your h value. So we need to, for this function, just evaluate the function at 2 plus h. Okay, that's 2 times t plus, I'm sorry, t times 2 times 2 plus h squared plus 4. The function evaluated at 2 is 2 times 2 squared plus 4. Okay. So you can put these together. F of 2 plus h minus f of 2 is 2 times 2 plus h squared plus 4 minus 2 times 2 squared plus 4. Okay. And so you need to simplify this out a little bit. So you need to FOIL this inside quantity out. This will be 2 times 2 plus h squared is the same thing as 4 plus 4h plus h squared. There's a positive 4. That 4 is this 4. This is what we expanded. Oh, sorry, this goes here. Okay, so the 2 went with the 2 plus h squared. So expanded that. We need to multiply by 2, add the 4. And then I need to subtract whatever is here. So 2 times 2 is 4, 4 times 2 is 8, 8 plus 4 is 12. Okay, so let's continue simplifying this expression. This will be 2 times, that would be 8 plus 8h plus 2h squared. Plus 4. Let me see, minus 12. Let me take a look here. I feel like let me see if I've done all my algebra correctly. 2 plus h squared is 4 plus 4h plus h squared. Multiply by 2 and then add the 4. Okay. 2 squared is 4. 4 times 2 is 8. 8 plus 4 is 12. Okay. Let's see. Oh yes, and I had used this 2 already. Okay. So now let's take a look what happens. I get 8 plus 4 is 12, plus 8h plus 2h squared, minus 12. The 12s cancel, and you're left with 8h plus 2h squared. Okay. So that is what f of 2 plus h minus f of 2 simplifies to. Okay. That's a good step because we need to put that in for this limit expression. So we had f prime of 2 was the limit as h goes to 0, f of 2 plus h minus f of 2 divided by h. But we just simplified f of 2 plus h minus f of 2. We said that that was 8h plus 2h squared. Okay. Now we need to bring in the divided by h. And notice that there's some factoring that can happen to help us do this limit problem. The h factors out, plus 2h over h. The h's cancel because h is not equal to 0. H is just getting close to 0. 8 plus 2h. And then as h gets close to 0, this 2h gets close to 0, and our final answer is 8. So f prime of 2 is equal to 8, which is kind of what we thought was going to happen from our table of values. Okay, so hopefully the two examples I have shown that what we're doing here is that if you're given an a value and you're given an a plus h value, so h is given, okay, and you have some sort of function here, f of x. You evaluate your function at a to get f of a. Evaluate your function at a plus h to get f of a plus h. Okay. The average rate of change is that right here. Here is your secant line. Secant line. The slope of it is f of a plus h minus f of a divided by h. But as you take h smaller and smaller and smaller, so as you move h over to here, say smaller h, so you take something a little smaller. Here's your new a plus h value. You would compute a new line. Okay. That limit process that we were doing is we were trying to find the instantaneous rate of change right here. This line right here is called the tangent line. Okay. And by doing the limit as h goes to 0 of the average rate of change, so there's your average rate of change, but when you take the limit as h goes to 0, you get the instantaneous rate of change. Instantaneous rate of change at the value x is equal to a. This will turn out to be the slope of the tangent line, and we will see that probably in the next video.